Okay, so I have a cord here. It's actually an extension cord, and I'm going to pull it fairly tight here so that I can send a transverse wave of energy through this thing. Transverse wave, what I have is I'm going to displace my medium, which is the cord here. I'm going to displace it up and down, and the particles within the cord are displaced up and down as the energy wave travels forward. So the movement of the particles is perpendicular to the movement of the wave. So I'm going to displace this thing by pulling the cord downward, and when I release it, you can see the wave travel through the cord. And then where it's attached to the wall, we actually get a reflection of the wave, so that the wave travels back, and it's actually upside down, so that it's on top of the medium instead of bottom. So it's reflected so that it comes back in an opposite phase. Now, if I do this, if I'm able to displace the cord, at the same time, when it reflects, I displace it again, what we'll see is we can get a constructive interference in the middle, so that you get kind of a hump, or what we'd call an antinode, and you'll get nodes at the end. Now, if I pull this thing tighter, notice if we talk about the velocity of the wave traveling through the medium, the velocity is equal to the square root of the tension in the string divided by the mass to length ratio. That's your mu in the equation that you'll see. So the tighter I pull this, so here it is loose, I'm going to send my wave down and it reflects back. And if I pull it tighter, the wave reflects a lot more quickly, and it's actually hard to even see the reflection as it goes down. So now if I can send wave impulses down this thing in the right frequency, what I can get is what's called a standing wave. And so as I move that, you can see that, okay, if I just match the frequency perfectly, my up and down motion, that I've got a wave that's going down and back at the same time, so that the maximum's in the middle. And where the reflection occurs at both ends, it's cancellation, so that we have what's called a node. Okay, so the displacement at either end of the medium is 0, and the displacement in the center, okay, is up and down as the wave is coming down and reflected back. Now, if I can move this with twice the frequency, what I can get is twice as many, if I can match it perfectly. Okay, I'll get twice as many, okay, nodes and antinodes, or antinodes. I've doubled the antinodes to 2, and now I have 3 nodes, or essentially 2 humps in my wave pattern. This would be a standing wave where now you're seeing one full wavelength. Okay, the one previously was only a half a wavelength, which is how most guitar strings or musical stringed instruments vibrate. So now we have 2 antinodes, a node in the middle and 2 nodes in the end. Essentially what's happening here is we have destructive interference. The wave that's traveling on top and the wave that's traveling on bottom meet in the middle, and they cancel each other out, so there's virtually no displacement in the center. Now, if I can go even faster, triple my original frequency, I can set it up with 3 humps, or 3 antinodes in my medium. And if I can completely match that, and if I pull tighter, I have to move faster, so I'll fall out of phase here, which is what happened. But if I can go real fast, we can get 4 for just a second. Okay, and those are your standing waves. And now's the part where I press the remote and shut off the camera.